Voximplant's voice AI orchestration platform enables a wide variety of real-time voice AI pipelines. In this demo, we will build a fully cascaded voice AI pipeline with natural interactive speech using Voximplant's end-of-turn detection and VAD voice activity detection. We will also use Voximplant's OpenAI's Responses API connector with another LLM vendor to show the OpenAI-compatibility feature of the connector. Before we review the code, let's first take a look at a fully cascaded architecture with separately controllable speech-to-text, large language models, and text-to-speech elements. We will also layer in end-of-turn detection for natural speech interactivity. Code you control on Voximplant orchestrates interactions between the user and external STT LLM and TTS engines. When the caller connects, the agent speaks a brief introduction. Then, when the user responds, we will use a streaming speech-to-text engine for transcription. Voximplant's VAD and turn detection will sense when the user has stopped speaking and will trigger passing the transcribed user speech as text to the LLM. When the LLM generates a response, that text will immediately be passed to a streaming text-to-speech engine where the audio will be piped back to the caller. If the caller starts speaking to interrupt the AI agent, then we will immediately stop the TTS response and handle a new user speech input. The cycle continues until the call is done, or until we want to do something different, such as a transfer. This demo will handle inbound calls, but the same process works for outbound calls too. Now let's take a look at the code that runs in VoxEngine, Voximplant's serverless orchestration environment. See the description for docs and guides on setting up the VoxEngine environment. Since this is an incoming call example, our logic starts on an incoming call alerting event, where we promptly answer the call. Then we will start to set up the pieces of our voice AI pipeline, starting with speech-to-text using Create ASR. Voximplant has several speech recognition providers built in. For this demo, we will use Deepgram and give it some keywords we expect. Then we configure our LLM connector. In this case, we will use the OpenAI Responses API client connector. But instead of connecting to OpenAI, we will demonstrate the OpenAI API-compatible capability to connect to the hardware inference vendor Groq. They allow us to use a Llama model, which we will specify in a moment. Next, we configure real-time text-to-speech that streams the audio output as soon as it is ready. Voximplant supports several streaming TTS options and a bring-your-own WebSocket interface. We will use Inworld here. Now, we will set up turn-taking. See the description for a link to the full Vox turn-taking helper library code with loading instructions. We pass the call and STT objects to the turn-taking helper, as well as specify some voice activity and turn detection thresholds. We can also change end-of-turn policy options to adjust how easy it is to interrupt the agent in common speech scenarios. On end-of-turn, we send the transcription to Llama 3.3. The last part of our pipeline setup is routing the LLM response text to the text-to-speech player. Since this is real-time voice AI, we will send this text for audio playout as soon as possible. Now that the pipeline is set up, we can attach the caller's media to the STT engine and the TTS engine to the caller. With our pipeline fully implemented, lastly, we tell the LLM to greet the user. Now let's hear what this sounds like on a live call. We can use Voximplant's built-in debug dialer to test.
Hello, thank you for calling.
Can you tell me about Voximplant?
Voximplant is a cloud-based platform for building voice and video communication apps, providing tools for developers to create custom
Do they support turn detection?
Yes, this device supports.
Visit Voximplant AI to get started with your voice AI app today.